Picture Voyager 2, a small, brilliant machine, racing through the darkness of space. Alone, it drifts farther from home than any human-made object before it, a silent messenger carrying our curiosity into the unknown. Launched in 1977, it was humanity's boldest mission, a grand tour of the outer planets fueled by hope, ingenuity, and a desire to see what lay beyond the familiar. After transforming our view of Jupiter and Saturn, Voyager 2 set its sights on Uranus, a pale blue-green enigma, shrouded in mystery and distant sunlight. Uranus spins on its side, as if toppled by a cosmic accident, creating seasons that last decades. Its axis is tilted at a dramatic 98 degrees, making it unique among all the planets in our solar system. Before Voyager 2, Uranus was just a faint dot in our telescopes, its true nature unknown. Astronomers could only guess at what secrets it might hold. We knew it was an ice giant, with water, methane, and ammonia ices, a few moons, and faint rings. But little else. Its atmosphere and inner workings remained a mystery, waiting to be revealed. Its atmosphere looked calm, almost featureless. Was it truly dormant, or hiding something beneath its clouds? The planet's bland appearance only deepened the intrigue. Voyager 2 was our only chance to find out. No other mission had ever come close, and none would follow for decades. The journey required a daring gravitational slingshot around Saturn, a feat never before attempted. This maneuver would hurl Voyager 2 toward Uranus at incredible speed, using Saturn's gravity as a cosmic catapult. After nearly a decade in space, battered by radiation, Voyager 2 pressed on. Its systems endured the harshest conditions, surviving the cold and the emptiness of the outer solar system. As it neared Uranus, anticipation on Earth soared. We were about to see the seventh planet up close for the first and only time. Scientists and engineers gathered, holding their breath for the images and data that would soon arrive. Uranus orbits nearly 3 billion kilometers from the Sun. Sunlight there is 400 times weaker than on Earth. The planet receives only a faint, cold glow, making exploration even more challenging. We expected a sluggish, quiet planet with a weak magnetic field. Theories suggested little activity, a world frozen in time and space, but the universe loves surprises. Just when we think we understand, it throws us a curveball. Voyager 2 was about to deliver one of the biggest, sending back data that would puzzle scientists for decades. Its discoveries would challenge everything we thought we knew about Uranus, all because it arrived at a moment no one could have predicted. Timing, as it turned out, would be everything. The story of Uranus was about to change forever, opening a new chapter in our quest to understand the outer reaches of our solar system. January 24, 1986. After 8 long years voyaging through the vast emptiness of space, Voyager 2 finally reached the mysterious planet Uranus, becoming the first and only spacecraft to ever visit this distant world. There was no time to linger. Voyager 2 was moving at over 15 kilometers per second, racing past Uranus in a high-speed flyby. The spacecraft had only a few precious hours to capture as much data as possible before it sped away forever. Every maneuver, every camera angle, and every instrument reading was meticulously pre-programmed months in advance. In this fleeting encounter, every second was critical, and there was no room for error. As Voyager 2 swept past, its cameras revealed a pale blue-green orb, shrouded in a seemingly featureless atmosphere. Uranus appeared calm and almost serene, with only the faintest hints of clouds or storms visible in its upper layers. Yet beneath this tranquil appearance, Voyager 2 uncovered astonishing secrets: 10 previously unknown moons, 2 new rings encircling the planet, and a day on Uranus that lasted just over 17 hours, spinning on its side in a way unlike any other planet in our solar system. The probe's sophisticated instruments measured the planet's frigid temperature, its strange hydrogen-rich atmosphere, and the powerful tilted magnetic field that enveloped Uranus. Voyager 2 came within just 81,500 kilometers of Uranus's cloud tops, using the planet's gravity to slingshot itself onward, setting course for Neptune, the next and final stop on its grand tour. Every observation, every experiment was carefully planned for this brief, once-in-a-lifetime window of opportunity. For the first time in history, humanity saw Uranus's major moons, Miranda, Ariel, Umbriel, Titania, and Oberon, up close, revealing their battered surfaces and mysterious features. But as the data streamed back to Earth, a new mystery began to unfold, one that no one had anticipated. The readings from Uranus's magnetic field and radiation belts were perplexing. unlike anything Voyager had encountered before. These measurements didn't match what scientists had seen at Jupiter or Saturn, nor did they fit the predictions of existing planetary models. The initial triumph in mission control quickly gave way to confusion and curiosity, as the team realized they had stumbled onto something truly unexpected. Voyager 2 had answered many questions about Uranus, but in doing so, it left us with an even deeper puzzle to solve. Something about Uranus's space environment was profoundly unusual, hinting at hidden processes deep within the planet. In just a few hours, we had flown through a cosmic riddle, one that would challenge scientists for years to come. The answers would not come quickly. It would take decades of research, new theories, and future missions to even begin to unravel the mysteries Voyager 2 uncovered at Uranus. Voyager 2's first surprise at Uranus was as strange as it was unexpected. Its magnetosphere, the vast magnetic bubble surrounding the planet, was almost completely empty. Instead of a bustling region filled with charged particles, Voyager found a near vacuum, a ghostly void where scientists had expected activity. Unlike Jupiter and Saturn, whose magnetospheres are crowded with plasma streaming from their volcanic moons, Uranus's magnetic environment was eerily quiet. The spacecraft detected almost no plasma, no energetic particles, just emptiness. This was baffling, and it immediately set Uranus apart from its giant neighbors. Yet, at the very same time, Voyager 2 discovered something even more astonishing. Uranus possessed some of the most intense radiation belts in the entire solar system, second only to Jupiter's. These belts were packed with high-energy particles, swirling rapidly around the planet. How could a magnetosphere so empty still host such fierce, punishing radiation? The contradiction was stark, and it left scientists scratching their heads. It was a paradox, like stumbling across a barren desert only to find a raging river cutting through it. The two realities seemed impossible to reconcile. Theories abounded. Some suggested Uranus's extreme tilt, with its axis nearly lying on its side, might be responsible. Others pointed to the planet's faint rings, or to unknown processes deep within its atmosphere. But none of these ideas could explain both the emptiness and the radiation belts at once. The data from Voyager was clear and consistent, but the explanation remained elusive. Every new analysis only deepened the mystery. For decades, Uranus became the solar system's oddball, its secrets locked away in the fleeting hours of Voyager's brief flyby. No other spacecraft would visit for generations. Scientists pored over the data, year after year, but the contradictions stubbornly remained, defying every attempt at a solution. An empty magnetosphere and intense radiation belts, two sides of a puzzle that no one could solve, a cosmic riddle that refused to yield. The answer, it seemed, was hidden in the timing of that single, fleeting encounter. Voyager's snapshot of Uranus was just that. A moment in time, not the whole story. Uranus was guarding its secrets well, keeping its true nature locked away behind a veil of mystery. The key to the mystery, scientists realized, might not lie within the planet itself, but in the ever-changing environment around it. The solar wind, the sun's activity, and the timing of Voyager's arrival. Voyager 2 had captured a single extraordinary moment, a snapshot, not the norm. The true story of Uranus was still out there, waiting to be uncovered. And that mysterious moment would haunt planetary science for 40 years, fueling curiosity and debate, and reminding us how much we still have to learn about the outer reaches of our solar system. For nearly 40 years, scientists tried to explain Voyager 2's baffling findings. Computer models couldn't replicate an empty magnetosphere with intense radiation belts. With only one flyby, we assumed what Voyager saw was Uranus's normal state. Textbooks described Uranus as quiet, its moons as geologically dead, based on this single snapshot. The lack of plasma suggested inert moons, unlike the active satellites of Jupiter and Saturn. But what if we'd only caught Uranus in a temporary state? The mystery shaped our view of the entire system. Decades passed, the puzzle unsolved. The truth was hidden in the timing, a fleeting event, not a permanent feature. The breakthrough came in 2024. Scientists asked, what was the Sun doing during Voyager's flyby? They discovered Uranus had just been hit by a powerful solar storm, a rare coronal mass ejection. Such events reach Uranus only about 4% of the time. Voyager 2 arrived at the exact moment Uranus was reeling from this cosmic tempest. Modern models reconstructed the event. A shock wave and dense solar material had just swept over the planet. The data Voyager sent back wasn't typical. It was Uranus's reaction to a solar storm. The empty magnetosphere and fierce radiation were temporary, not permanent. The 40-year-old mystery finally had context. The solar storm explained it all. The storm compressed Uranus's magnetosphere, scouring out the usual plasma, leaving it empty. Then, it injected a fresh supply of electrons, which were rapidly accelerated, creating intense radiation belts. Voyager 2 arrived just after this cosmic cleaning. If it had come days earlier, it would have seen a normal, plasma-rich environment. The paradox vanished. Both mysteries were two effects of the same cause. Uranus wasn't always so strange. Voyager just caught it at a rare, violent moment. Our understanding of the planet was transformed. The real Uranus is likely far more typical than we thought. The solar storm discovery forced a rethink of Uranus's moons. For decades, their apparent inactivity was blamed on the lack of plasma. But the storm would have swept away any evidence of moon activity too. It's possible the moons are geologically active, venting water vapor or gases, just like moons at Jupiter and Saturn. The evidence was simply erased before Voyager arrived. Now the idea of subsurface oceans and cryovolcanism on moons like Ariel or Miranda is back in play. The Uranian system could be far more dynamic than we imagined. The story of its moons is no longer closed. The solar storm didn't just solve a planetary mystery, it revived the search for life and activity in this distant system. Voyager 2's brief visit is a lesson in the limits of snapshot science. For 40 years, we mistook a rare event for the norm. The universe is dynamic. What we see in a moment may not reflect reality. Our knowledge of Uranus is less complete than we thought. The data is valuable, but it's a portrait of Uranus under duress, not its everyday self. We must ask, what is Uranus really like on an average day? Like a tourist visiting London during a royal wedding, we saw an extraordinary event, not daily life. To truly understand Uranus, we need long-term observation. A flyby gives a postcard, an orbiter gives the full story. The 2024 discovery makes it clear, our postcard was misleading. To know Uranus, we must go back. The new understanding of Uranus has reignited the call for exploration. Ice giants like Uranus are common in the galaxy, yet we know little about them. NASA's top priority is now a Uranus orbiter and probe, a mission to study the planet, its rings, atmosphere, and moons for years. An atmospheric probe will dive into Uranus's clouds, revealing its true nature. While we wait, telescopes like James Webb are giving us tantalizing glimpses. But only a dedicated mission can answer our biggest questions. Voyager 2, now in interstellar space, gave us our first glimpse and a 40-year mystery. That mystery is solved, but a new adventure awaits. The tilted ice giant is calling us back. The great cosmic ocean is waiting.